Dear students, we are solving problems under the topic linear programming problem by using simplex method, under which we are going to see the first type, that is, it has been categorized as maximization problem and all the constraints with lesser than inequality and a two variable problem. So this is the first type that we are going to deal with. So let us focus on the question now. The question is to solve the following linear programming problem using simplex method. Maximize z is equal to 5x1 plus 3x2 with respect to the constraints 3x1 plus 5x2 lesser than or equal to 15, 5x1 plus 2x2 lesser than or equal to 10, and x1 and x2 are greater than or equal to 0. Now we observe that this is a maximization problem and both the constraints are lesser than or equal to inequality. And this is a two variable problem because we have only two variables x1 and x2 in this problem. So now let us see how to solve such a problem. The given function is said to be the objective function. So we have to maximize the objective function. If it is a minimization problem, then first we have to convert it as a maximization problem and then proceed. Now since the given problem is of maximization type, we proceed further with simplex method directly. So now the objective function here is z is equal to 5x1 plus 3x2, and these two are the constraints given in the problem which are having lesser than or equal to inequality. In such a situation, in order to make this lesser than or equal to inequality as a equality problem, we have to add slack variables on the left hand side of the inequality so that these constraints will turn out to be equalities. So let us write the standard form of the LPP. Now in order to write the standard form of the LPP, we must see how many constraints are there in this problem. There are two constraints. So we will be adding two slack variables. So those slack variables will also be added to the objective function with coefficient 0. Now the slack variables that we are going to add is s1 and s2. And so the standard form of this problem will turn out to be maximize z is equal to what it is given as 5x1 plus 3x2, and we have to add two slack variables 0 s1 with coefficient 0 in the objective function plus 0 s2. Now these slack variables will also be added to the given constraints. So let us do that. So subject to the first constraint is 3x1 plus 5x2. Now we have to observe here that the slack variable s1 will be added with coefficient 1 and the slack variable s2 will be added with coefficient 0 in the first constraint. So the inequality turns out to be equality, and on the right we have 15 over here. And in the second constraint we have to, so let us take and write 5x1 plus 2x2. We have to add s1 with coefficient 0 now in the second constraint and s2 with coefficient 1, and the right hand side is 10. We do so in order to form the matrix 1 0 0 1. So this is the standard form of the given problem where these variables x1 comma x2 are and s1 comma s2 that we introduced all are greater than or equal to 0. Now these two variables x1 and x2 are known as non-basic variables. So these variables are non-basic. And the slack variables that we introduced in the problem are known as basic variables. So these are basic. Now after writing the standard form of the LPP, the next step is we have to find the initial basic feasible solution for the given problem. So the initial basic feasible solution is obtained by putting the non-basic variables x1 comma x2 to be equal to 0 in the given constraints, that is we wrote the inequality constraints. Now in these two constraints we have to put x1 and x2 as 0. So in the first constraint, if you put x1 and x2 as 0, we will be getting the solution as s1 is equal to 15. So that will be, so this will imply s1 is equal to 15. And in the second equation, if you put, so this is a second equation. In this, if you put x1 and x2 as 0, the solution will be s2 is equal to 10. So we obtain s2 is equal to 10. So these solutions give us the initial basic feasible solution to the problem. So having these initial basic feasible solution, we have to do the initial iteration. So now we have drawn the initial simplex table in order to perform the initial iteration. Now let me tell you how to fill in this table. The first column of this table is represented as CB. I will tell you what is CB. The second column is represented as YB. And the third column is represented as XB. And the variables that we have in the problem are x1, x2. The slack variables that we introduced are s1, s2. This is how we have to fill, and here we have to write ratio. Now at the top of xb, we have to represent it as cj. What is this cj? Cj gives us the cost of these variables in the objective function. If you see, here we wrote the standard form, and this is the objective function of the problem. What is the cost of x1? It is 5. Cost of x2 is 3. For s1 it is 0 and s2 it is 0. So we have to write 5, 3, 0, 0 at the top of the table. So 5, 3, 0, 0. Now first let us fill this YB. YB are the non-basic, that is basic variables that we introduced. That is, in the initial basic feasible solution, what are the solutions that we obtained? We got S1 and S2. That only we have to write under YB. So here S1 and then S2. And in XB, what are the values of S1 that we obtained in the initial basic feasible solution? S1 was 15. So that we have to write here. And S2 is 10. And that we have to write here. Then CB gives us the cost of S1 and S2 in the objective function. In the objective function, the cost of S1 and S2 are its coefficients, which are both 0. So that we have to write here. So 0. So as we do the further iterations, this column will be changing, and accordingly the CB values will also change. So you will understand it when we perform the iterations. Fine. Now we have to fill in this matrix x1, x2, s1, s2. So it is obtained from the standard form that we have written. That is, these are the two constraints. The first row will be 3, 5, 1, 0. So that we have to take and write. So 3, 5, 1, 0. And this 15 was the right hand side of the first constraint. That is what is this. And the second row will be 5, 2, 0, 1. So let us write that. So 5, 2, 0, 1. And the right hand side of this constraint was 10, and that only has come here. Now after filling up this table, let us perform the iteration. How to do that? We have to first find Zj minus Cj. How is that found? So see, 0 multiplied with 15 plus 0 multiplied with 10. Since both are 0, we will be getting 0 only here. Now for this column, it will differ a little. So remember, 0 multiplied with 3 plus 0 multiplied with 5 minus 5. So that will be, anyway this will be 0. So 0 minus 5, it will be minus 5. Next, for this column, 0 multiplied with 5 plus 0 multiplied with 2 minus 3. So it will be only minus 3. Then 0 multiplied with 1 plus 0 multiplied with 0, which will be both 0, and minus 0 is 0. And again 0 multiplied with 0 plus 0 multiplied with 1 minus 0 will be 0. Usually for the initial table, the Zj minus Cj value for x1, x2, s1, s2 will be the negative of the Cj value. So that directly we can take and write. So we have done this. Now we have to check whether all Zj minus Cj are greater than or equal to 0. If you see here, not all Zj minus Cj are greater than 0. We have negative values, and so the optimal solution is not attained. So now when we have negative value, we have to check out for the least negative value, that is the most the most negative value. So what is the most negative value over here? It is minus 5. So minus 5 is the most negative. So that will be entering the table. And the variable corresponding to that column is x1. So x1 enters the table. The column corresponding to the entering variable is known as the pivotal column, or it is also known as the key column. So this is known as the pivotal column. Now, when a variable enters, another variable has to leave the table. So out of these two variables, one of the variable has to leave the table. So in order to find which variable leaves the table, we have to find this ratio. Now in order to find the ratio, we have to divide this column, that is xb is known as the solution column. We have to divide the solution column by the x1 column only with those values which are greater than 0. Now if you see here, both the values are greater than 0. So what is the value corresponding to this 3? It is 15. So first ratio will be 15 by 3. So we have to write that over here. So 15 divided by 3. And that we know that it is equal to 5. Then the second ratio will be 10 divided by 5. So 10 divided by 5. And that will be 2. And out of these two ratios, we have to choose the minimum value. So what is the minimum out of these two? This 2 is the minimum. So that will be the leaving variable. So S2 will be leaving the table and x1 will be entering the table. So we have to introduce x1 and drop S2 in our next iteration. The row corresponding to the leaving variable is known as pivotal row. It is also known as the key row. And this element, that is the intersecting element, is known as the pivotal element, which is also known as the key element. So this is the pivotal column, this is the pivotal row, and 5 is the pivotal element. Now we have to perform the row operations in order to find the matrix for the first iteration. Now since this Zj minus Cj were not all greater than or equal to 0, we found the entering variable and the leaving variable, and we have to move on to the next iteration. So let us do that. So now in order to perform the first iteration, we have to again redo the table with the same type of, that is CB, YB, XB, X1, X2, S1, S2, and Cj will always remain the same as the coefficients of these variables in the objective function remain the same. So 5, 3, 0, 0. So as in the previous table, Cj also remains the same. The only difference comes here is the column. First we have to rewrite the column YB. Previously the column YB was S1, S2. But now since x1 has entered the table and s2 is leaving the table, we have to drop s2. And at the place of s2, we have to introduce x1. So here now the table will change as S1 will remain as it is. Now instead of S2 we will have X1. And now the values of CB will change, but for S1 the cost is 0 only in the objective function. Whereas for X1, what is the cost? It is 5. So in the objective function the cost of X1 is 5. So that we have to write here. So 5. Now XB is the solution space which has to be redone. So all these values will has to be newly found. Now how are we going to find these values is the question. So now there are various methods for finding it actually. So the method that I am going to adopt is row operations. Now if you see, this row can be named as row 1 and this row can be named as row 2. So these are the old rows. And the new rows that we are going to find has to be named as row 1 dash. And this row has to be named as row 2 dash. So now these are the new rows that we are going to find. First, what we have to do, we have to see which is the pivotal row. Now R2 is the pivotal row. So this is the old pivotal row. Now the corresponding new pivotal row we have to find. How we have to find that? We have to divide the old pivotal row by the pivotal element. So listen very carefully. This is the old pivotal row R2. Now the new pivotal row is the corresponding same row which is represented as R2 dash. Now the new pivotal row R2 dash will be equal to, I will write here, the new pivotal row R2 dash will be equal to the old pivotal row. What is the old pivotal row? It is R2. So this row has to be divided by the pivotal element. So R2 divided by, what is the pivotal element? It is 5. So R2 divided by 5. So we have to divide this row completely by 5 in order to find the new row 2 dash. Now what is the first element over here in this pivotal row? It is 10. So 10 divided by 5, it will be 2. So that we have to write here. So this is the new pivotal row R2 dash. R2 dash is R2 divided by 5. So 10 divided by 5 is 2. Next is 5 divided by 5, which will be 1. Next is 2 divided by 5, because this element 2 divided by 5. So that we have to write here. It's always good to maintain the fractions, and at the last end of the problem you can convert it as decimals. So do not write in decimals. Try to maintain the fractions till the end of the problem. And then the next element is 0. So 0 divided by 5. So that will be 0 only. So 0 divided by 5 is 0 only. And this element is 1. So 1 divided by 5, it should be 1 by 5. So remember, the new pivotal row is represented as R2 dash, and that is equal to the old pivotal row divided by the pivotal element. The pivotal element is 5 and the old pivotal row is represented as R2. So we have found R2 dash to be equal to R2 divided by 5. So this is the formula that you have to remember. Now we have to find the new S1 equation, that is R1 dash. So we have to find R1 dash. That is equal to, the formula is old S1 equation. What is the old S1 equation? This one. And it is represented as R1. So it will be, R1 dash will be equal to R1 minus the element corresponding to the pivotal element of the pivotal column is 3. That is, for S1, from the pivotal column, what is the element? 3. So R1 dash is equals to R1 minus 3 multiplied with the new pivotal equation R2 dash. So this is the formula. You should remember this. That is, the new S1 equation is equal to old S1 equation minus the element corresponding to S1 in the pivotal column multiplied with the new pivotal equation R2 dash. So this may seem to be a little difficult for you in the beginning, but as you practice more problems, this will become handy for you. So you need not worry. So we have to find R1 dash, which is equal to R1 minus 3R2 dash. Now in order to find this, we will do this calculation separately. So first we will take and write this R1. So what is R1? So now if you see here, R1 is this row. So let us take the elements of R1 and let us write here. So R1 I am writing. That is, the elements of R1. First element is 15. And then 3. And then 5, 1, 0. So I have taken and written the elements of R1. Next is what? 3R2 dash I need. So R2 dash is this one. This column, this row that we have newly found. That has to be multiplied by 3. What is the first element here? 2. So I am going to write 3R2 dash. So 3 multiplied with 2, which is 6. And then 3 multiplied with 1, which is 3. Then here 3 multiplied with 2 by 5, which is 6 by 5. 3 multiplied with 0 is 0. And then 3 multiplied with 1 by 5 is 3 by 5. Now after writing this, actually what we want, R1 minus 3 R2 dash. So subtract it. So when you subtract R1 minus 3 R2 dash, so you have to subtract at all the places. So 15 minus 6, it will be 9. And then 3 minus 3, 0. 5 minus 6 by 5. What is 5 minus 6 by 5? 5 is the LCM. So 25, because we have to cross multiply. So 25 minus 6. It will be 19 by 5. So 19 by 5. And then 1 minus 0. So 1. 0 minus 3 by 5 will be minus 3 by 5. So now we have found this R1 dash. Let us take and fill this row. So it is 9 and then 0, 19 by 5, 1 and then minus 3 by 5. So now we have found the new S1 equation and X1 equation. Both are done. Now we have to again find Zj minus Cj. So we have to find Zj minus Cj now for this table. So as I told you, 0 multiplied with 9 plus 5 multiplied with 2. So 0 multiplied with 9 is 0. So plus 5 multiplied with 2 is 10. So here we have to write 10. Whereas for these it will change a little, that is 0 multiplied with 0 plus 5 multiplied with 1 minus 5. So it will be 5 minus 5, which is 0. So this, if you see, 0 multiplied with 19 by 5, which is 0, plus 5 multiplied with 2 by 5 minus 3. So let me show that calculation here. 5 multiplied with 2 by 5 minus 3. So this 5 and 5 will get cancelled. What is 2 minus 3? It is minus 1. So this will be minus 1. 0 multiplied with 1, 0. 5 multiplied with 0, 0. Minus 0, 0. Don't forget to do this minus of this Cj value. Okay. So 0 multiplied with minus 3 by 5, which is 0, plus 5 multiplied with 1 by 5, which is 5 will get cancelled, 1. So 1 minus 0, it will be 1. So we have obtained all the Zj minus Cj value. Is all the Zj minus Cj greater than or equal to 0? No. We see that one of the value is negative. So if you have a negative value, then the optimal solution is not attained. You have to further proceed the iteration. Now the most negative will enter the table. But we see that there is only one negative value, and obviously this variable will enter the table. So this becomes the pivotal column now, and x2 has entered the table. In order to find the leaving variable, what we should do? We have to divide the solution space xb by the value of the entering column, that is the pivotal column, and for only the positive values of the pivotal column. Now if you see, both the values are positive here, so we have to find the ratio for both the values. So for this, it will be, the ratio will be 9 divided by 19 by 5. So 19, that by 5 can be written here like this. So it will be 45 divided by 19. The ratio is 9 5 times is 45 divided by 19. And what is that value actually? What is 45 divided by 19? It will be some 2.3. So 2.3. And here it will be, the xb value is 2. So 2 divided by 2 by 5. So 2 multiplied by 5. So this is equal to 5. Now here we have 2.3 and here we have 5. So which is the least of these two values? 2.3 is the minimum. So that will be leaving the table. And so what is that value? It is S1. So S1 leaves the table and X2 enters the table. So in the next iteration, S1 has to be replaced by X2 as we did in this table. So this is the pivotal column. This is the pivotal row. And 19 by 5 is the pivotal element. Having this, we have to perform the row operations and find the second iteration. That is, perform the second iteration. And remember, this row has been represented as R1 dash and this is R2 dash. Now I have formed the new table of the second iteration. Now all these remain the same as in the previous case. The change comes only here, that is YB. YB, we saw that S1 was leaving the table. If you see, S1 was leaving the table and instead of that, X2 was entering the table. So in that case, we have to replace S1 by X2. So this alone will be changing. So X2 and here X1 remains as it is. So here we have to write X2 and here X1. And what is the cost of X2 in the objective function? It is 3. So that 3 we have to write here. And we know that for X1 it is 5. So we have to write the cost from the objective function. Now all this we have to find now. Now again we have to perform the row operations. Now maybe we can represent this as row this one is row 1, represented as row 1, then row 1 dash. We can represent this as row 1 double dash, and this can be represented as row 2 double dash. And how to find? First, what we have to check, as I told you, we have to check for the pivotal equation. Now what is the pivotal equation? R1 dash is the pivotal equation. So we should find R1 double dash first, the new pivotal equation. So R1 double dash we have to find first. What is R1 double dash? It is the old pivotal equation divided by the pivotal element. Now here the pivotal element is 19 by 5. Old pivotal, that is the pivotal equation, is R1 dash. So the new pivotal equation will be equal to the old pivotal equation R1 dash divided by, what is the pivotal element? It is 19 by 5. So divided by 19, and then that by 5 can be written as in multiplication. So multiplied by 5. So this is R1 double dash which we have to newly form. Next, what about R2 double dash? As I told you, R2 double dash will be old R2 dash, okay, minus, what is the element in the pivotal column corresponding to R2 dash? It is 2 by 5. So that we have to write R2 dash minus 2 by 5 multiplied with, now this has to be multiplied with the new pivotal equation, that is, this is the new pivotal equation R1 double dash. So that we have to write. So that is the formula. So it is same like how we did here. If you compare these two with that, you will understand it. So patiently if you go through, definitely you will understand how I am writing this R1 double dash and R2 double dash. Now let us perform the operations. Now in order to find R1 double dash, we have to multiply R1 dash by 5 by 19. So what is this R1 dash actually? So let me write that here. R1 dash are these elements, that is 9, 0, 19 by 5, 1, minus 3 by 5. So let me write all that. Just for my convenience I am writing. So 9, 0, 19 by 5, 1, minus 3 by 5. Now this R1 dash has to be multiplied by 5 and divided by 19. So that is 5 multiplied with R1 dash divided by 19 we have to do. So this first element, if you see, 9 multiplied with 5 is 45. So 45 divided by 19 we get. Then this is 0. So 0 multiplied by 5 by 19 is 0 only. Now 5 by 19 multiplied with 19 by 5 will be 1. And then 5 by 19 multiplied with 1 will be 5 by 19. Then 5 by 19 multiplied with minus 3 by 5. So let me write here. That is 5 by 19 multiplied with minus 3 by 5. This 5 will get cancelled, and so we get minus 3 by 19. So we have found the new R1 double dash equation. That is this equation we have obtained. So we can update it here. So 45 by 19 and then 0 and then 1 and then 5 by 19 and then minus 3 by 19. So we have obtained this row R1 double dash. Next step is we have to find R2 double dash. Finding R1 double dash, we have completed this row. Next we shall find R2 double dash. For that, first we should take and write R2 dash. So R2 R2 dash. What is that? That is this one. That is these values. R2 dash is 2, 1, 2 by 5, 0, 1 by 5. So let us take and write these values here. After writing this, we shall find this one, that is 2 by 5 R1 double dash. So 2 by 5 R1 double dash. We have to multiply 2 by 5 with R1 double dash. Where is R1 double dash? This row. So if you see in this row, we have to multiply each value by 2 by 5 and we have to write. Now if you see, the first value is 45 by 19. So 45 by 19 multiplied with 2 by 5. So it will be 5 1 times, 5 9 times, 9 2 times is 18. So the first value is 18 by 19. Then the second value is 0. 0 multiplied with 2 by 5 will be 0. Then 1 multiplied with 2 by 5 will be 2 by 5 only. And then 5 by 19 multiplied with 2 by 5. So it will be 2 by 19. And the last value is minus 3 by 19. So minus 3 by 19 multiplied with 2 by 5. So 2 by 5. 3 2 times is 6. And so it will be minus 6 divided by, and 19 multiplied with 5, which is 95. So 19 multiplied with 5 is 95. So 3 2 times is 6 in the numerator. So minus 6 by 95. Now this is over. Now after this, what we have here, R2 dash minus 2 by 5 R1 double dash. So we have to subtract each of the values now. Now 2 minus 18 by 19. What it will be? 2 minus 18 by 19. So if you see, 19 is the LCM. And then 2 multiplied with 19, which will be 38. So 38 minus 18. What is 38 minus 18? It will be 20. So that will be 20 by 19. So therefore 2 minus 18 by 19 is 20 by 19. Now next is 1 minus 0 is 1 only. Then 2 by 5 minus 2 by 5 is 0. 0 minus 2 by 19 is minus 2 by 19. Now 1 by 5, now already we have a minus over here. Minus of minus will become plus. So it will be 1 by 5 plus 6 by 95. We know that the LCM is 95 and 5 multiplied with 19. So 19 plus 6. So it will be 25 by 95. So what is 25 by 95? 5 times, and this is 5 19 times. So 5 by 19. So we get 5 by 19. So we have obtained these values. So we have to take and substitute this in the table. So do this substitution very carefully. So here we have to fill up with these values that we have obtained. The first value is 20 by 19. So it is 20 divided by 19. Then 1 0. So 1 0. And then minus 2 by 19. Minus 2 by 19. And finally we have 5 by 19. So 5 by 19. So we have found R2 double dash. That is the new x1 values we have obtained. So do the calculations very patiently and carefully. Now after finding all these values, we have to find the Zj minus Cj value. So here if you see the first value, that is, this is the solution space. It will be 3 multiplied with 45 by 19. So let me write that here. 3 multiplied with 45 by 19 plus 5 multiplied with 20 by 19. So what that will be? What is 3 multiplied with 45? So if you calculate that, it will be 135 divided by 19 plus 5 multiplied with 20 is 100. So 100 by 19. So since both the denominators are same, we can just add the numerators directly. So 235 divided by 19. So this is the value. So 235 divided by 19. Next, 3 into 0 plus 5 into 1, which is 5. Minus 5, it will be 5 minus 5, 0. 3 into 1, 3. Plus 5 into 0, 0. So 3 minus this 3. So here we have this value, no? So that is how. So if you see here, 3 into 0 plus 5 into 1, 5. 5 minus 5, 0. 3 into 1, 3. Plus 5 into 0, 0. So 3 minus 3, it is 0. Now next, 3 into 5 by 19. So that is 3 into 5 by 19 plus 5, this one. Yes, 5 into minus 2 by 19. So that will be minus 5 into 2 by 19. So what we get, 5 3 times is 15. So 15 by 19 minus 5 2 times is 10. So 10 by 19. So that will be 15, since the denominators are same, 15 minus 10 is 5. So it will be 5 by 19. So this is 5 by 19. And then finally here, 3 into minus 3 by 19. So it will be 3 into minus 3 by 19 plus 5 into 5 by 19. So 5 into 5 by 19. That's equal to 3 times is 9. So minus 9 by 19 plus 5 times is 25 by 19. So that is equal to 25 minus 9 divided by 19, and that is 16. So 16 divided by 19. So that we have to write here. So 16 divided by 19. Now here we observe that all the Zj minus Cj are greater than or equal to 0. So this is positive, and these both are positive. And these values give us the solution space. So remember, that is the value of x1 is 20 by 19, x2 is 45 by 19, and the maximum value of z is equal to 235 divided by 19. So let us take and write these values. So since all Zj minus Cj were greater than or equal to 0, we have obtained the optimal solution, where the value of x1 is equal to 20 by 19. The value of x2 is equal to 45 by 19, and the max value of z is equal to 235 divided by 19. So these are the required optimal solution. So when we take the decimal values, x1 will be equal to 20 divided by 19 is 1.05. So this will be the value of x1. The value of x2 will be equal to 45 divided by 19, which is 2.37 after rounding up. So these are the values of x1 and x2, and therefore the value of z is equal to 235 divided by 19, which on simplification gives us 12.37 after rounding up the value, and this gives us the maximum value of z. And this is how we have to perform the simplex method algorithm. Hope you found this video beneficial to you. All the best. Thank you.